calculation of induced EMF. Calculation of induced EMF as per the Faraday's law. As per Faraday's law, induced EMF is equal to rate of change of magnetic flux now E can be written as d phi by dt. Now d phi by dt, the flux can be written here d by dt of B dot S. So now in this expression, if we are removing the dot product, we will get Bs cos theta. E is equal to d by dt of Bs cos theta. So E is here d by dt of Bs cos theta. So there are two things we can say here. One, we can say B constant, d by dt of S cos theta. Another term we can say plus S cos theta as a constant and dB by dt. So these two are very important relation. So we can say induced EMF can be produced or induced EMF can be developed by two ways. In one of the way, we are keeping magnetic field constant. So either we are changing the area or we are changing the angle. When we are changing the area or angle, so we require motion of the conductor or motion of the loop. Either the motion your translational motion or motion is your rotational motion or combination of both these motion. So since in this calculation motion of conductor or motion of loop is needed, so EMF associated with the due to the motion of conductor is called motional EMF. But in this case, we are keeping the area and theta as constant. We are changing magnetic field. So here motion of conductor is not required. So here magnetic field is variable. So this variable magnetic field produces induced EMF because of the induced electric field. So here this term we can say induced EMF due to induced electric field. So induced EMF due to induced electric field. So the whole EMF induced EMF can be split into two parts, and these two are very much different and very much conceptually different parts. So one we can say motional EMF, another is the induced EMF due to induced electric field. So both these two we will study separately. So first see what is the cause of motional EMF. So see,